Hi guys, today we're going to be doing compound angles for grade 12. Now, there's four types of compound angles, and that's sine A plus B, sine A minus B, cos A plus B, and cos A minus B. Now, we're just going to be applying this rule. This will be given in your data sheet. Let's just go through a quick example of how this works. Let's say, for example, I had sine x plus y, and I had to expand that would then equal, now what we're going to do is, if you look at this x now becomes our a, and this y now becomes our b. So we'll have here sine x times cos b plus, we have a plus sign here, cos, oh, why did I put b here? Sine cos y plus cos x times sine y. And there's how you expand it. It's as simple as that. Let's look at one more example. We're now going to look at if I had cos x minus y. So if I had cos x minus y, we look at this compound angle right here, and we'll have cos A, which in this case is x, times cos B, which in this case is y. Now, if you look here, we have this minus right here, and this minus becomes a plus. And that's important. So, since we have minus in this question, it's now going to become plus sine x times sine y. So, what we're doing here is just the expansion. Key tips for you guys to realize when doing this is, let's find the patterns with the sine and the cos. So what are the patterns here? We're going to draw a line straight through the middle, and we're going to look at our patterns for the sine and the cos. So with the sine, the plus or minus stays the same when we expand it, whereas for cos, the plus and minus change when you expand. Okay, another key thing to note is for the sine, it goes sine times cos, whereas here you'll have a cos cos, or a sine times sine. So basically, that's how you can notice which one you're working with. So there's two criteria. One is the operation change, and the other is, are you going cos cos or sine sine? Now that you guys understand how to expand it in example, looking at the patterns, let's move on to doing some work with this expansion and contraction of using these compound angles. So on the left hand side, we have our expansion exercises, and here we have our contraction exercises. You got to be able to do both in this section. So we go in and to look at this first one, where we have cos A plus 60 minus cos A minus 60. So we're going to put our equals. Okay, Now when we're expanding this, we know with the cos, it'll go cos alpha times cos 60 minus, because this is a cos, sine 60 times sine alpha. Now we have a minus sign here. When we're working with this minus sign, I would recommend putting the minus sign down and then opening up a bracket. It makes it a lot easier to work with to make sure you don't get your signs mixed up. And then I'm just going to expand within this bracket. So I'll have cos alpha times cos 60, and there's a minus sign there, so this is going to be a plus sine 60 times sine alpha. Okay, just mind the writing's a bit squashed. With this expanding, it just goes really far along and it's hard to fit into the screen. So we then go and work with this, and we're going to now simplify this. So we know that cos 60 is equal to a half, so we'll have a half of cos alpha minus, we know the sine of 60 is equal to root 3 over 2, so this is root 3 over 2 sine alpha. Now we're going to apply a distributive law, this negative times a positive and this negative times this positive. So I'm going to now have minus, and we know the cos of 60 is a half, so I'm going to have half of cos alpha. We're going to have minus again because we're applying our distributive law, and this here will then be the sine of 60 is root 3 over 2 sine alpha. So now if we look here for our equal sign, we'll see that this term right here cancels out with this term right here, and I'll just be left with negative 2 root 3 over 2 sine alpha, which will just be these terms here will now cancel off, and I'm going to just have negative root 3 sine alpha, and that's our final answer. So if you're looking at this question, you're understanding it better, I would recommend doing the next two and then see if you can get it right. It will really help you learn it. Even if you get it wrong, just look at the correction afterwards and see where your mistakes are. Practice is really helpful in maths, and even when you're watching other videos, don't just let the person teaching give you all the answers. Do the work, it'll really help you. Let's go on to the next one, expansion. So we're going to go equals. So let's expand this. We'll get cos A times cos 60 minus sine 60 times sine A. Okay, and we have a minus sign again, so we're going to use the same technique where we put a negative. We open the brackets. And here I'm going to have sine A times cos 30. Now we're going to remember our rule when we deal with the sine trigonometric function, we keep whatever sign is in it. Those two words sound the same. When I'm referring to sine now, I'm talking about the plus and the minus. So we're going to keep the minus. and we're going to have cos A times sine 30. Okay, the writing is a bit squashed because this expansion takes so much space, and I only have so much space on my screen, so please mind with me. So we know that cos 60 is equal to a half, so I'm going to have half cos A minus sine 60 is root 3 over 2 sine A. Cos 30 is root 3 over 2. We're going to apply this negative into the distributive law like we said earlier. This negative is going to go here. And we're going to have minus, we know the cos of 30 again is root 3 over 2, minus root 3 over 2 sine A plus sine 30 is a half. So I'm going to have plus a half cos A, and now I'm left with cos A minus root 3 over 2. Oh, sorry. It's going to be root 3 sine A. Now let's check our work. Let's go through a way of checking our work. So we're going to take this first part of this function here, and we're going to look at this first part here. Did we expand it correctly? So I have cos A, correct, cos 60, correct, minus sine 60, correct, times sine A, correct. We put in the minus sign from here. We're going to now move on to our other one, where we go here, and I have sine A, correct, times cos 30, correct, minus cos A, correct, times sine 30, correct. So we just look right through here. We know we did it right. On to our next step. Cos 60 is a half. Right. Sine 60 is root 3 over 2. You check. Correct. We keep in the correct signs. Negative root 3 over 2 plus that. And this is our final answer. Let's move on to the next one with this question right here. Now we have a root 3 on the outside, so we can use the same technique we used earlier. We have a negative on the outside where we put the root 3 here, and then we open a bracket to expand. And now I'm going to have cos x times cos 30 plus sine 30 times sine x. We go minus, we're going to open a bracket again, and I'm going to have cos x times cos 60, and from the minus it's now going to change to a plus, plus sine 60 times sine x. Okay, and now we go into simplify these. You can still keep this brackets if it's one step too many to do in a row, so I'm going to do the same thing. So I'll have root 3 open brackets, the cos of 30 is equal to root 3 over 2. So I have root 3 over 2 cos x plus the sine of 30 is a half sine x, closes brackets, minus, open brackets, the cos of 60 is root 3 over 2 cos x plus the sine of 60 with the cos of 60 is a half. Cos of 60 is a half, so I made an error here. The cos of 60 is a half plus the sine of 60 is root 3 over 2 sine x. Now let's apply our multiplication to this. So I'm going to multiply here, and then I'm going to multiply to this other term here. And I'd be left with 3 over 2 cos x plus root 3 over 2 sine x minus a half cos x minus root 3 over 2 sine x. Now, do any of these terms cancel off? Yes, this term right here cancels off with this term right here. In my next line, I will basically have 3 over 2 cos x minus a half cos x, which then equals 2 over 2 cos x, which then just equals cos x. Okay, I hope you guys are getting them right. Let's move on to the contraction exercises. Let's start up with this one right here. And here I have sine x cos y minus cos x sine y. So I know I'm dealing with my sine compound angle. And since I'm dealing with my sine compound angle, I know that this sign is going to change. This sign right here, this negative, is going to stay a negative. So I'll have x minus y. And it's that simple. On to the next question. We have, let me highlight the question. This question right here. I have a cos and a cos and a sine and a sine. So I know I'm dealing with the cos compound angle. I'll have theta. I have a negative there, plus 4 theta. Now these are like terms, so it'll equal cos of 5 theta. To the third question, right here. So I have a cos and a sine, and then a cos and a sine again. So here, they're trying to trick you. And the reason they're trying to trick you is because normally it's in the form cos sine plus sine cos. Okay, but here they have it in a different way. And I just want you to think about this. If I have xy, or if I have yx, and I'm multiplying these two, aren't they the same? The answer is yes, they are the same term. Yes, they are. So it's still the same thing because we multiply, and because we multiply, those two terms can be in a different order. So I have cos and sine, and then sine and cos, or cos and sine. They're different. I know I'm dealing with the cos compound angle. I'll put which is in my first cos. That's what's important. 14. I'll change this here now to a negative, minus 6, and then there will then give me the cos of 8 degrees. Okay, now we're looking at this last one, and this here gets slightly trickier because we have something like a compound angle in a compound angle. Now we know this is a contraction exercise, but what happens if you have a question like this not in a contraction exercise? I have sine cos and then cos sine. when dealing with this question, it may get a bit confusing to deal with this x minus 20. So what I will do is I'll say let x minus 20 equal theta. So then it'll be rewritten as sine theta times cos 20 plus cos theta times sine 20. Now the question doesn't even have a cos in it, so we have to now substitute back in after we contract them. So I have a sine and a cos and a sine, so I know I'm dealing with the sine compound angle. There's a plus there, so it'll be theta plus 20. And in this form, we're now going to substitute the 20 back in. So I'll have sine of x minus 20 plus 20, and then I'm just going to have sine x. Let's move on to the next section. I hope this was helpful. If you have any questions, leave a comment down below. We're now going to be looking at questions where they want us to have a value using the compound angles. And let's look at this first one where we have cos 15. When doing these questions, a lot of the time you're going to be thinking, what are the special angles I can work with? And the special angles you can work with here is that that's equal to cos 45 minus 30. Because 45 minus 30 is 15. And I can now expand this into cos 45 times cos 30 plus sine 30 times sine 45. Okay, and we know that cos 45 is equal to root 2 over 2, and we're going to have that times the cos of 30, which is root 3 over 2, plus the sine of 30, which is a half, times the sine of 45, which is root 2 over 2. Okay, and then root 3 times root 2 equals root 6. So I'm going to have root 6 over 2 plus root 2 over 4. And we can just pop this into our calculator and we'll get root 6 over 2 plus root 2 over 4. And that's going to give us 2 root 6 plus root 2 over 4. Let's now look at this next question over here. So here I have cos 70, cos 40 plus sine 70, sine 40. So I know I'm dealing with my cos. We have an expanded version. Let's just contract it. So I have 70 minus 40. And that's going to give me the cos of 30, which is a special angle, and we can work this out. Cos 30 is equal to root 3 over 2. Now let's look at this question right here. In this question, we have the negative sine 40 cos 10 plus cos 40 sine 10. When we look at our rules for expansion, we always have the positive first. So I'm going to rewrite this with the positive first. So we're going to have cos 40 times sine 10 minus sine 40 times cos 10. Now you may be thinking, how can we do this? And the reason we can do this is, if I have 4 minus 3, which equals 1, or if I have negative 3 plus 4, it still equals 1. And that's the same concept we use in here, because this right here is one term, and this right here is another term, just like how these are one term and one term. So that's the reason why we can swap these, and it's still algebraically correct. So now that you understand that, we can then contract this, and we know we have cos sine, sine cos. We know we're dealing with our sine. We always put the one in the front first. So I have 10 minus 40, which equals sine the negative 30, which now equals negative sine 30. The reason for that is, if I have sine negative x, is just negative sine x, so we're using that same principle. And then we know the sine of 30 is a half, so I'll then get equals negative a half. On to this last question. So I have sine and sine and cos and cos. As I've told you guys earlier, you can correct this, because we normally deal with our cos first. So I have cos of 55, negative cos 55 times cos 5 plus sine 55 times the sine 5. I can now take out a negative as a common factor, and I'm left with cos 55 times cos 5 minus sine 55 times sine 5. And then here we can then contract those brackets, and I'll get cos of 55, we have a minus here, it'll become a plus 5, close brackets, and then we're going to get negative into cos of 60, and we know the cos of 60 is a half, so we'll just get negative a half. Okay, I hope this was helpful on some techniques that you may be able to use. If you have any other questions or want more examples done like this, leave a comment down below and I'll be sure to do it. So now let's look at some tricky application questions. We have one with a proof-in, and then using that proof to then get to the next answer. So we're going to start off with this first part, which is 1. We're going to say, which side are we going to work with? Now, I always like working with the side you simplify. And if you look at the left hand side and right hand side, the left hand side is the side you simplify. So we're going to write our left hand side, and that then equals sine theta times cos x plus cos x times, cos theta times sine x plus sine theta times cos x minus cos theta times sine x. Now we're going to look what are our like terms here. Okay, we have a sine theta and a cos x. Do we have another sine theta and a cos x? Yes, it right here, sine theta and cos x. So these two are like terms. You can add and subtract them. Are there any other like terms? We have a cos theta and a sine x, and we have a cos theta and a sine x. But as you can see, we have a positive here and a negative there, which means that these two will cancel each other out. And I'm now left with sine theta times cos x plus sine theta times cos x, and I'm left with 2 sine theta times cos x. Now I have that my left hand side equals my right hand side. So that's the proof for that. Now we need to then use this thinking to show that sine 43 plus sine 17 equals cos 13. And this can be intimidating. Another time you guys do get intimidated with questions like this, leaving it blank and stuff in tests, but you don't need to with the preparation we're doing here. So we saw the thinking that we used last time. There's something to do with compound angles. Okay, and again we're going to work with the side to expand. So let's work with our left hand side. Remember what I said earlier, which is when you're dealing with these expansions and they want you to get to a value, use your special angles. So the key part here is we have this 13, okay, and we have this 17, and we have this 43. How can we link all of them with the special angle? What special angle allows us to do that? And that's 30, because this sine 43 can be written as sine 30 plus 30, and then I have plus sine 30 minus 30, and now 30 minus 13 is 17. And now that I have that, I'll then expand this, because I have a special angle to work with and I have something that has a 13, and we're just going to see what happens. Okay, you don't have to see the answer straight away, just let's see what happens. And this will become sine 30 times cos 13 plus cos 30 times sine 13 plus sine 30 times cos 13 minus cos 30 times sine 13. So what I'm going to do here is I'm going to convert all of these 30s. So sine 30 equal to half. So I'm going to have half cos 13. What cos 30? Root 3 over 2 plus root 3 over 2 sine 13 plus sine 30 we know is a half cos 13 minus root 3 over 2 sine 13. And if we look here, let's go and look at our like terms. What are our like terms here? So we have cos 13. Do we have another cos 13? It's right here. So these are our like terms. Now let's look here. We have a sine 13 and we have another like term here. So the positive and negative for the sine 13 will then cancel each other out. And now we're left with a half cos 13 plus a half cos 13. And this now equals just cos 13. So our left hand side equals our right hand side. Before doing this next question, I want you guys to just try it out and see if you can do it. I am going to do it as well afterwards. We're now going to do another show that question. So we're going to show that root 3 cos x plus sine x equals 2 cos x minus 30. And again, I looked at my left hand side, look at my right hand side, which is the side I get to expand, and it's my right hand side. Or should I say simplify? I can work more with my right hand side. The left hand side, I do some tricks, some hectic tricks, like some backflips and somersaults and things. And I just work with the right hand side. This is a form I recognize. I know how to work with it. So I'm going to go 2 into cos x times sine. Oh, I'm dealing with my cos here. So I have cos x times cos 30 plus sine 30 times cos x. And that now equals 2 into, we know that cos 30 equals root 3 over 2. So we have root 3 over 2 cos x plus sine 30. Sine 30 is a half. Oh, this is a sine x here. Times sine x. So we'll then have a half sine x. And now we can just apply our distributive law. Go 2 into this, 2 into that, and you'd be left with root 3 cos x plus sine x. And that is compound angles. I hope you guys enjoyed the video. Leave a comment, like, subscribe. Anything else you may need, please let me know. You can also check out more of our stuff on our website, aftermathtuitions.com.